Bismillahirrahmanirrahim. Welcome back to my channel. Today, what I'm gonna do, I have my computer, which is right here, that is connected to USRP N210. As you can clearly see, this is connected to my computer, to my MacBook using Ethernet, and this is just a simple receiver flow graph. Now, on the other hand, on my other machine, I have PlutoSDR, which is also connected. So I have a simple flow graph where I'm going to transmit from PlutoSDR, and so here's the graph for it. It's just a simple PlutoSDR graph which is going to transmit a signal, and I'm going to try to receive it on my USRP that is connected to my other computer. So this is my Adalum PlutoSDR, which is right now connected to my PC, to my laptop, and I'm going to transmit a signal from my laptop, which is this, to that has a simple flow graph like this. So I'm going to try to transmit that signal from here using my PlutoSDR, which is connected here, to my USRP, which is connected to this laptop, just to show you the functionality. How does this work? So what I'm going to do, I'm going to simply go here. Right now my PlutoSDR is connected. So guys, I made a video on how to install GNU Radio on your MacBook. If you just simply follow that particular tutorial, you don't need to install separate softwares for your RTL SDR dongles, for your hack RFs, for your Pluto SDRs, and all the other type of SDRs which are there which are available, like for example USD. So all you need to do is just simply plug in your SDR and make a flow graph on GNU Radio and go on with your daily work. So this is how that simple it is. So this is just a simple flow graph where I have a signal source. As you can clearly see, I have a signal source that has a QT range of 150 megahertz, 100 megahertz, all the way up to 1 gigahertz. That is configured here in this, as you can clearly see. So signal frequency, that is just the variable which is a range in range QT, which is right here. That is connected to my Pluto SDR sync. That is an default IP address of 192.168.2.1. Same thing, and I'm looking at this signal in a time sync and a frequency sync. That's all I'm doing, which is connected. So this Pluto SDR sync is actually representing this physical device that is connected to my computer, to my laptop. Now the next thing is, on the other hand, I have a simple receiver out. So this USD driver, which is representing this particular box, which is connected to, which is USRP N210, which is connected to my laptop via this, and I'm just simply monitoring this signal, exactly the same frequency in my QT GUI range as my transmitter. So what I'm going to do, I'm just going to simply play the signal. So I'm just simply going to go here and I'm going to play this. So once I play this signal, here are some of the options. So I'm not receiving a receiver flow graph from the same flow graph. So these are the two things that I need to focus on: signal frequency and transmitter attenuation. So this is my signal right now that I'm sending at about 140-50 kilohertz, around 150 kilohertz and 40-50 kilohertz, and this is what I'm seeing right here. So what I'm going to do, I'm going to change this. When I tested the system, I want to see the signal at 900, because this GUI can go up from 100 megahertz all the way up to 1 gigahertz. So I'm going to see that particular signal at 968 megahertz. There's a reason for it. Well, let's just simply look at this signal at 960 megahertz. Let's see if I'll be able to see something at 960 megahertz. All right, 967 megahertz. I can see there's a lot of things going on. If I were to zoom in, I would see there's a lot of things going on right here. So there's like a bunch of stuff. So you can just right click it, hold it, and then try to zoom it. It will zoom into your signal. All right, so 967 megahertz. This is what I'm tuned into. I'm going to simply go ahead and I'm going to run my flow graph here. Right, once I run this, alrighty. So what I'm going to do, I'm going to simply tune into 967 megahertz. There we go. Here we go. Let's just simply go here. And now I am tuned into 967 megahertz. I can see a presence of a signal that is going on, off, on, off, on, off, on, off. I can see this. Alright. So when I change this, now what I'm going to do, what have I done? I have used an attenuation thing. So let's try to attenuate the signal and let's see what happens on the other hand. So this was an original signal that you can see in a spike coming in, going at about negative 64.10 dB. That's where my signal is at, about 966, 67, and about 64 dB, negative 64 dB. Let's try to attenuate this signal. Let's try not to attenuate this signal. So lower the attenuation down. And let's see what happens to my signal. So right now when I go here, I look at this signal. Nothing much has changed actually. No, it has changed. Now when my attenuation factor went down, this went from negative 64 all the way up to negative 48. Now because my signal is supposed to, when the signal is not attenuating, it's supposed to go up. And when I have no attenuation, let's see what is the maximum that I can get. So this is zero attenuation in my signal when I'm transmitting it. Now what is it? What is the maximum that I can get? Negative 49. Alright, let's try to attenuate my signal. Let's change this number to 29 dB. Let's see. Right, let's look at this. It went all the way down to negative 77 dB. So this is just to show you that indeed this is being transmitted from my PlutoSDR with a simple flow graph, and is being transmitted and received by my USRP N210. So I hope you like this small tutorial. If you have any questions, leave it in the comment section. Don't forget to like and subscribe to my channel.